Hey, welcome everybody to 13.3, trig functions of any angle. So this section, at least part 1, is all about us creating a triangle in a coordinate plane and finding our 6 trig ratios based off of that triangle in the coordinate plane. And this is leading us eventually to being able to, in a coordinate plane, figure out our sine, cosine, and tangent with using our unit circle. Before we start today, I want to do a quick warm-up. I'm going to let you pause the video and try these two problems and see if you remember how to find the missing sides. Alright, there it is. So one of them was a 45-45-90 triangle and the other was a 30-60-90 triangle. Alright, here's what we're going to do in this section, at least this part of 13.3. We're going to let theta be any angle in standard position. So that means that in standard position, the beginning ray or the initial side starts right at the x-axis as normal. The terminal side could be in any quadrant. I'm just going to draw it over here to create my picture, but that could end in any quadrant. So that is my angle theta. So theta is an angle in standard position with a point xy on the terminal side. So what I'm going to do now is on my angle, I'm going to say there's a point here that is x comma y. Off of that point, I am going to create a triangle. And I always create my triangle with the x-axis. So I'm going to create a triangle with the x-axis. And this is kind of strange, but that theta, if I find sine, cosine, tangent of that, it'll be the same value as if I find sine, cosine, tangent, etc. of a theta I put right here. It'll be the same value, which is kind of strange. And here's what's happening with the triangle I just created. This is the x value. It's the distance I go to get to this spot. This is going to be what I'm going to consider the y value. And as you can see, since theta is right here in the corner, that would be opposite. X would be adjacent. So again, x is going to be the adjacent side and y is going to be the opposite side. We're going to call this distance right here r, and that is standing for the radius. And this is again leading us into using our unit circle, which is why we're calling it a radius, even though I haven't created a full circle. But I could create a circle that point is on. And that radius then is the hypotenuse. Now, based off of this, to find the radius r, I could do square root of x squared plus y squared, which, by the way, you don't have to write this down, but all that is the Pythagorean theorem rearranged, because it's the 2 legs squared equals the hypotenuse squared, and then I just square rooted both sides. So it's just the Pythagorean theorem rearranged. And my sine, cosine, and tangent, instead of saying opposite and adjacent, I'm going to use x, y, and r. And a lot of times you don't have to use x, y, and r. You can still just think of it as opposite, adjacent, and hypotenuse. But there are a few situations, specifically when my angle or my xy ends on one of the axes, that I do want to think of it this way so that I can find my answers. I'll explain more in a little bit. So sine is opposite over hypotenuse, so that would be y over r. Remember, cosecant is the reciprocal, so y over r. And now I want to tell you that the radius will never be 0 because I'm talking about a triangle that exists. Not a triangle, a circle that exists. I can't have a circle with a radius of 0. It's not possible, because then the circle wouldn't exist. So we know for sure that r will not be 0, but I don't know for sure that y will not be 0, and I cannot have y on bottom of a fraction, or not y, I can't have 0 on bottom of a fraction, because it would make it undefined. So, if y is 0, which trigonometric function is undefined? Remember, undefined means it's not possible. Calculator gives you an error message. I can't divide something into 0 pieces. So, it is undefined when I am taking cosecant of theta. And then let's move on. So, cosine of theta is adjacent over hypotenuse. So, we're going to say that's x over r. And secant then is r over x. And I can't have x is equal to 0. X can't be equal to 0. So when x is equal to 0, secant of theta is undefined. And then remember, tangent is opposite over adjacent. Again, x cannot be 0. And cotangent is x over y, and I can't have y equal to 0. So cotangent is also undefined when y is 0. You don't have to necessarily have these memorized, because we're going to find that when I try to find those trig values, they're just going to end up being undefined because I'll have 0 on bottom of a fraction. But I just wanted you to be aware of the fact that quite often, actually, we are going to get an undefined answer, and that's going to happen when my point ends up on one of the axes. Let me show you what we're doing with example 1. So what's going to happen is they're going to give you a specific point. In part A, they're giving us a point 3, -4. You're going to sketch for yourself a little coordinate plane, and I'm actually going to graph this point 3, -4. So 1, 2, 3 along the x, 1, 2, 3, 4 along in the negative direction along y. So there is my angle, and technically it's starting here and ending here. Now remember, I said we always create a triangle with the x-axis. So I'm going to go down to the x-axis right there. I put my theta right next to the origin always. So theta goes next to 0, 0 always. And then let's go ahead and label some stuff. So because this is a point 3, -4, this value here is 3. This value here is -4. And I just don't know what r is. I don't know what the hypotenuse is. So luckily I have this handy dandy Pythagorean theorem formula rearranged for me already. So I can right away plug these in. Don't forget, when you evaluate, you have to put it in parentheses. So I've got 3 squared plus -4 squared, which ends up being 9 plus 16. So that's 25. R equals 5. So that's my radius. And now I want to make a comment to you quick. You might want to write yourself a little note about this. The radius will always be positive. The radius will always be positive, because a radius is specifically talking about a distance to the edge of a circle. Now these other spots are specifically talking about a point that is graphed in the coordinate plane. So those can be negative because they're not really meaning distance, which is kind of hard to get our head around. But the r is meaning a distance, so it has to be positive. Now, I'm just going to go ahead and find my 6 trig ratios based off of what I've got here. And if it helps you out, you can label them x or adjacent, y or opposite, and r or hypotenuse. So according to the new thing we learned today, sine is y over r, so that is going to be -4 over 5. Cosecant is the reciprocal, so -5 over 4. Cosine x over r, that would be 3 over 5. And so secant is 5 over 3. Tangent is opposite over adjacent, so -4 over 3. Or you know what? I should have said it in our new language here. Y over x. So that would be -4 over 3. And then cotangent, flip it, so -3/4. Now if you thought that was super easy, it does get harder. So please watch example B. I want to show you what happens when I have a denominator that I need to rationalize. For example B, -1, 8 is a point on the terminal side of the angle. So again, that just means I am going to graph my point. -1, 1, 2, 3, 4, 5, 6, 7, 8. So there is my ray that goes right through the point -1, 8. I want to always draw my triangle with the x-axis, though it could be very tempting to go to the y-axis since it's closer, but no, always go to the x-axis. Theta is always right here by 0, 0. And now the x value is -1, the y value is 8, and I don't know what r is, so I am going to have to find it. And by the way, in case you're like, wow, how'd you get -1 and 8? That came from the point right there. Remember, a coordinate point is always x, y. That's how I got x and y. All right, I need to find r using my formula. R is the square root of 8 squared plus -1 squared, not forgetting to put parentheses around it. That's important. And that ends up being 65. Now, if I could, I would do upside down division on 65. Now, when I try to do that, I just end up with 13 for an answer, which is a prime number already. So there's no pair I can pull out of there, so square root of 65 is as simple as it gets. And that is my r. Now, here's how this makes our problem a little bit more annoying. When I'm trying to do sine, which is y over r, that means it's 8 over the square root of 65. We must have our answers in simplest exact format, so this is not correct as a final answer. I need to do the rationalizing thing again, like we have done in some of the other sections this chapter. So I'm going to multiply by square root of 65 over square root of 65. I'm going to end up with 8 square roots of 65 over 65. And then remember to find cosecant, I take the reciprocal. Like we did in one of the other sections, I would recommend flipping the original one, because if I flip the original one, I just get right away square root of 65 over 8. Now, quick comment, if I had flipped the final answer, I would have had this, which I would have had to then rationalize again. So it's to your advantage when you're flipping it, flip the original one before you simplified it, because then you don't have to do more work later. Let's do cosine. Cosine is x over r, so -1 over square root of 65. Again, I have a square root on bottom, so I need to multiply by the square root of 65 over the square root of 65. I get the negative square root of 65 then over 65. And again, for secant, flip the original one, not the final answer. So when I flip that, square root of 65 over 1, well, and it's negative, by the way, so that's just negative square root of 65. And thank goodness when I do tangent, which is y over x, there is no radical, so I just get my answer for there is -8. Flip it, -1/8. Go ahead and pause, rewatch, try things, write down some questions, flip to the back when you're ready. In the backside, I'm going to talk about what happens when our angle or our dot lands right on one of the axes. So, it's called a quadrant angle when that happens. So a quadrant angle happens if your theta, your angle, lies on an axis. Now, we're going to do an example of each type. And actually, I want to do an example quick first, and then I'm going to say more up here. So let's go down to example 2a. It says theta equals 90. Now, they did not give us a specific point. So if you are not given a distance, assume the distance is 1. So I'm going to draw my 90 degrees. And there's really, when you do these, theta is just the distance to the ray. Again, I don't know what the distance is, so that point right there is 0, 1. Now here's where it gets really confusing. Notice that it's 0 because it hasn't gone left or right along x. So x is 0. It's 1 because I just told you if you're not given a distance, it's 1 to your dot, so y is 1. That it also means that r is 1, because this also represents the radius of the circle right now. And here is where I don't really have an opposite adjacent hypotenuse. I don't really have a triangle. It's like a triangle that was just flattened. So these are the situations where you really want to think about the y over r, x over r, y over x I just taught you on the front page in order to figure these ones out. So now y over r would be 1 over 1, so sine is 1. Reciprocal of that for cosecant, so that's also 1. Cosine is x over r, that would be 0 over 1. 0 over 1 is 0. Now watch what happens when I do secant. I end up with a 0 on bottom, so that is one of my undefined answers. For tangent, it's y over x, which is again 1 over 0, so that one's undefined. But when I flip that for cotangent, it's 0 over 1, which is 0. All right, now notice this time the radius and y were the same value, Sometimes they're going to be opposites of each other depending on where my angle lands. I'm going to give you some information right now, and I want to say you don't necessarily have to write this down because this isn't really something you're going to memorize. I just want you to be aware of the fact that the radius is the same as the distance here, and sometimes it's going to be the same as one of my values, and sometimes it's going to be the opposite. I'll say more about that in a little bit. But just so you know, the example we just did was this one. If theta lands right on the y-axis, so that point is 0, comma, the radius, and the radius for that one is the same as what r is. That's what we just discovered with example 2a. The radius and r are the same. So we've got all sorts of different situations going on. If my theta lands right on the x-axis, so it's kind of like a flat angle that never started, I guess. In this situation, the radius and x are equal to each other and y is equal to 0. And then the next two situations, the radius is going to be the opposite of what I have. Here's y, and then I'm going to show you this one in example B in just a second. But when I draw this out here, this is a point, and it's going to be a negative value because it's in the negative direction for x. So x is the same thing as the opposite of the radius, but note the radius is still positive. We just turn the radius negative in order to find what x is. Now, I think that is kind of confusing, so let me show you that example right now with example B, and then we'll come back and draw one more in a second. Here's what I mean with that. So for example B, they actually did give us a point. They gave us -3, 0. I'm going to graph that. So there's my point, -3, 0. Now, when I said just a second ago that x is equal to -r, here's what I meant. X is equal to -3. That is -r. So regular r is +3. Now, you probably could just figure that out using logic and not with these formulas up here. So again, those are kind of just for general information. You don't have to memorize them or anything. I'd say just use logic when you're solving these. And you know the radius always has to be positive. With that said, let's just go back and write the other one really quick. Again, for general knowledge, kind of showing you where these things are coming from. The last one is when my quadrant angle ends up landing down here. And that is at the point 0, -r. And this time y is 0, x is -r, and again the radius is still positive. You know what, I just said that wrong. Sorry. I meant to say x is equal to 0, y is equal to -r. Alright, let's go back and solve example 2b. So again, if you know these y, r, x, r, etc., this goes really fast. So again, sine is y over r. Y is 0, r is 3. That is 0. When I flip that for cosecant, I get 3 over 0, which is undefined. Cosine is x over r. X is -3, r is 3. That is equal to -1 for cosine there. And the reciprocal of that is -1 still for secant. Tangent is y over x. Y is 0, x is -3, 0 over -3 is 0, and when I flip it for cotangent, I end up with undefined. Alright, I am going to give you a chance to pause and try C and D. When you unpause, I'll have them showing, and then make sure that you write down any questions you might have about what I've just been talking about. Quick comment before you try C and D. Remember, if you are not given a radius or not given a point, assume the radius is 1. So assume it's a unit circle. A unit circle has a radius 1 if we're not given a point. Again, pause and try them, and then when you unpause, they'll have them showing. All right, there's our answers. Go ahead and pause, write those down, make sure those make sense. Again, write down any questions you have for me, and we will talk about this more in class. Talk to you soon. Thanks for listening.